Hey, I hope you are doing great. In this video, I wanna say about four metrics: perplexity and cross entropy, and also byte per character and byte per byte. So without further ado, let's go. So let's go to the first metrics, entropy. What's the meaning of the entropy? Entropy measures how much information on average a token carries. The higher the entropy, the more information each token carries, and the more bytes are needed to represent token. So what is the meaning here? For example, I go to here. Entropy is a intuitive concept. It means, for example, here I like. After I like, we can predict some tokens, for example, tea, coffee, music, and etc. So here is a higher entropy. It means a lot of words can be replaced here. Another sentence can I say example is about, for example, a dog is blah blah blah. So here you think about barking. So here for the second sentence, the dog is blah blah blah. The higher the entropy is low, because we know the next token must be barking, for example. But here I like has a lot of token can be replaced here. It is a concept of the entropy. And we use entropy, for example, in a data set. We check the distribution of the data set about measure the entropy on it. For example, a sentence for abnormal, for example, a cat is coding. It is abnormal sentence. Here entropy is high, but for a normal sentence, for example, a dog is barking is a normal sentence, so here the entropy is low. The second one, cross entropy. Cross entropy is same as loss for LLM for training process. For example, we have a data set and we training model on it, and we wanna to measure the difference between between the trained data that the model predict by and the real data set. If the cross entropy is low, it means the model learns the distribution of the dataset. So if the cross entropy is high, it means the model is not trained very well. So it needs to retrain again, because the cross entropy is high. So it means the model doesn't learn the distribution of the dataset yet. The third one is perplexity. Perplexity is same as cross entropy, but has a subtle nuance between these metrics. The unit of this metrics is not. So it's not very sensible for human. I mean, it's not sensible, not. But we using log here. I don't care about the mathematic of this concept here for this video. So it is perplexity is a more sensitive for people. So if the perplexity is high, for example 4, 10, 20, it means the model is unpredictable. Same as cross entropy. It means the model doesn't learn the distribution of the training data set. But if the perplexity is low, it means the model learn the distribution of the training data. So the fourth one is BPC, byte per character, or another one byte per byte. It's not it also has a subtle nuance between there. Byte per byte is a standard version of BPC. Is not just the difference is a standard version of this. The fourth one is a byte per character, and also byte per byte. Byte per byte and byte per character has the same concept, but has a subtle nuance between there. The byte per character is represent for efficiently of the model comparison. Same as cross entropy. For example, if the can say again the example here. For example, token has a two option, A and 2. We can represent these two tokens with a 1 byte. A, for example, 0, B, for example, 1, or vice versa. But when we have a fourth option, A, B, C, D, we need 2 bytes for represent these numbers or alphabets. And so we need more entropy and also more byte per character. If the I can in a simple way, for example here as you see, if the average character per token is 2.67 and cross entropy is 6 byte, the BPC is 2.25. It means for each character we need 2.25 bytes for represented. This is the 4 metrics that I want to say in this video. Thanks to watching the video. But the one note that you must notice, Perplexity is one use case is very interesting. For example, we have a data on the internet and we want to check our data on the internet is be one of the training data of our model or not. For example, ChatGPT, and we have a site. We want to check that our site is used for a training process of the ChatGPT or not. If the perplexity is low, for example, we send a sentence and paragraph our website to the ChatGPT. If the ChatGPT can predict very well, it means that our site also one of the source for training data of the ChatGPT, and we know that and after that we see that the perplexity is low. But if the perplexity is high, we can notice that our website is not one of the training data for our processing the training data. So thanks for watching this video. See you later.